So hello everyone, welcome back to my YouTube channel. So today we'll be doing data collection and understanding of data. So in our first video we understood Python for data analysis, where we saw what is data analytics life cycle, how does it work, what are the types. Then we understood about Python NumPy library, Pandas library. So now today we'll be doing data collection and its understanding. So what is data collection? Data collection is when you identify, just wait. Yeah, you identify and pinpoint the exact question. Then when you determine what type of data is needed. So these are the prerequisites of data collection. Determine what type of data, decide on your data source, and then you collect the data. So collecting data is often collecting the right type of data. Is it quantitative or qualitative? Assessing and processing quantitative data is easier because it involves raw numbers and digits. On the other hand, processing qualitative data such as customer reviews or feedback is more complex. Now, identify the potential data sources from where pre-packaged data can be obtained or data could be extracted. So basically, जब आपके पास when you have numerical data, it is easy because you have to just take the numbers as input, like A is equal to in input, enter a number. Now, when we have to take a customer review or a feedback, in that case, maybe the review would be long, or maybe the customer does not want to give any review or feedback. So sometimes it becomes complex. So next comes what are the types of data we can see. So first of all, we have structured data, unstructured data, and semi-structured data. So structured data, like in the case of, I think you all must have done database management system. In that we study MySQL, or you may be knowing CSV files that have a Excel type format. These are all structured data that have a defined type, format, and structure. Defined type, format, and structure. Then we have semi-structured data. That is textual data files with discernible pattern that enables parsing, such as XML data files that are self-describing and defined by XML schema. So this is your semi-structured. CSV can come in semi-structured also. Basically, it is a structured format, but take MySQL as a structured format. Then we have quasi-structured. This is not mentioned here, so I'll mention it here. Quasi-structured. So basically, quasi-structured means textual data that can be formatted using efforts, tools, and time. I've written for semi-structured also that it is textual data with patterns, therefore easy parsing. Unstructured PDF images, these all have no inherent structure by themselves. So this was about the types of data. Now there are some more types in terms of the values you take. First is numerical. Numerical means made of numbers, age, weight, number of children, shoe size. Categorical means number of made of words, eye color, gender, blood type, ethnicity. Like suppose you say sizes in shirts, t-shirts, XL, L, small, medium. In numerical data, you have continuous or discrete. Continuous means infinite options. Age, weight, blood pressure. Blood pressure can vary from one person to the other. Discrete means It is finite options. A shoe size can normally vary from 1 to 10 maximum. There may be exceptions. I may not say that there are no exceptions. Now, in terms of categorical, you have ordinal and nominal. Ordinal means data as a hierarchy. Pain severity, satisfaction rating, mood. Nominal means data there is no hierarchy. Eye color, dog breed, blood type A plus B, A, B minus, and so on. Now next, what are the types of attributes? So let's first see the photo to your left. It shows data types are of two types, qualitative or quantitative. Qualitative contains categorical variables, quantitative has numerical variables. We have seen nominal, ordinal, discrete and continuous. Now in continuous we have interval and ratio. So this is under quantitative data. Let's see. There are different types of attributes. First is nominal. Nominal is ID numbers, eye color, zip codes. Ordinal means rankings, grade, height. Interval, calendar dates, temperature, interval. Ratio scale means temperature in Kelvin, length, time, counts. So these are all examples to make you understand what is interval means, like we have seen in mathematics also, interval from 1 to 10. So these are all intervals. Ratio scale means temperature. Let's see now the next topic. Now we'll go to some mathematical part, that is measuring the central tendency. First we'll see this mean median mode. I hope you all may be knowing about this. So we'll study that first. Measure of central tendency. So first of all, we have mean. So I'll create a formula sheet here. I'm on n. Then we have median. This is your mean. Then you have median. Median is basically the middle value. And then we have mode. Median formula L plus n by 2 minus B G into W. Then you have mode. Mode formula is mode. First I'll write and then I'll explain. L plus Fm minus Fm minus 1 upon Fm minus Fm minus 1 plus Fm minus Fm plus 1 into W. Now I write it here because it may not be visible. Mode is equal to L plus Fm minus Fm minus 1 plus divided by Fm minus Fm minus 1 plus Fm minus Fm plus 1 multiplied by W. So now let's understand the formulas. Now mean is sum of observations upon total number of observations. I think this part would be clear. Median. Median formula says L lower limit of the median class plus n by 2 minus CF upon F. Cumulative frequency upon frequency into the interval size of the, let's say we have 10 to 20. So it will be W will be 20 minus 10, 10. How many values are there in between the interval is basically your. So I'll write median in an easy way so that you all remember the formula. n by 2 minus Cf upon F into H. Mode. Now this formula says mode is equal to L plus Fm. This is the frequency of the modal class. Now Fm minus 1 is frequency of the class preceding the modal class. Fm plus 1 succeeding. So I'll write here precede, and this one is succeed the modal class. Modal class. And W, I have told you the width of the interval. So this was about your mean, median, mode. I'll not be solving questions on this part because these are the basics of. Now after that we'll study skewness and interquartile range. So this part should be crystal clear, and I hope it is. If it's not, please practice this part because this is the basics. Now next we'll go on to skewness. Now this is really important for data analytics. What is skewness? It is in a unimodal frequency curve. Unimodal frequency curve with a perfect symmetric data distribution. Symmetric data distribution of mean, median, and mode, all at the same center value. Data in most of the real applications are not symmetric. They may be either positively or negatively skewed. We'll see in the graph where we can say a mode occurs at a value greater than your median. So let's see. So this is the first graph. So here we have a straight line. So here itself we have mean, median, and then mode. That means it is symmetric. I think this would be simple, symmetric data. Now let's draw the second graph. Okay. So let's say we have mode. This middle part is your median, and this final line is your mean. So this means it is positively skewed. Now, positively skewed means where mode occurs at a value smaller than the median. Mode smaller than median. I am drawing it in a very easy way to remember in your exams because this question is really important. Then we'll draw a graph like this. Here you have your mean first. Mean. Then of course you'll have your median. And then your mode. So this type of graph is negatively skewed. Negatively skewed means mode occurs at a value greater than your median. So I think this part would be clear. So after this we'll understand some terms like dispersion, range, and then we have to understand interquartile range. So what is dispersion? Dispersion of a data is used to understand the distribution of data, how it is distributed. We can also check for variations. So dispersion, let's write it. Dispersion, it shows the distribution of data. It helps us understand the variation of data. So this is dispersion, and range is basically the easiest dispersion of data or easiest dispersion of data or measure of variability. Range formula we can write range is equal to highest minus lowest value. I'll put it in a box. So let's take an example. We have 1937. Let's take a case study. Suppose I'm standing on a election day in front of a election camp. Suppose for the college president, let's say. Now the college has raised a restriction on the age. A restriction is a interval type range. So it is suppose let's say 19 to not 37, we'll take 21. So your range in this case will be 21 minus 19. 2. So this will be 1. 11 minus 9, 2. Let's say now I have taken some voters from between the age of 19 to 37. Now someone asks me, what is the range of the data you took? Or the range of voters that you have, from data you have collected, what is the range of the voters' age? So I'll say it is 37 minus 19, the highest value minus the lowest value, approximately 18. Now this range is often influenced by outliers. Let's introduce this term, outliers. What are outliers? Outliers are extreme values that can change value of a range. Value of a range. Now let's see IQR. So first let's understand what are quartiles. Suppose the data for attribute X are sorted in increasing numeric order. Imagine that we pick certain data points so as to split the data into equal size consecutive sets. I'll write it down. Now we want to split data to equal size consecutive sets. So quartiles are basically points taken on regular intervals of data distribution where we are dividing it into equal size consecutive sets. So what is second quantile? We can say Q2 quantile. This basically is data point dividing the upper and lower values of a data distribution. Basically the median. Median में divide lower and upper values. Now four quantiles are three data points that split the data into four equal parts. Let's suppose this is a line. Why is it not working? 1, 2, 3, 4. So these are basically 1, 2, 3 data points that divide or split the data into four equal parts. This represents 1/4 of data distribution. The 100 quantiles are more commonly referred as 100 quantiles, are normally referred to as percentiles that divide the data to 100 equal sized consecutive sets. So this was the introduction to IQR. Now let's see IQR. So interquartile range. Interquartile range. So basically IQR is a range or the boundary between the first and the second quartile, and Q3 the boundary between the third and the fourth quartile. So let's see using a diagram because this may not be clear like this. 35. So 25%, 25%, 25%, and this is also 25%. Here we say Q1, Q2, and Q3 are 3 points. Your interquartile range is IQR is equal to Q3 minus Q1. Now, suppose we have odd number of elements, let's say 4, 8, 3, 3, 7, 2, 9. First sort them in ascending order. 2, 3, 3, 4, 7, 8, 9. Now divide them into four equal parts. So I can say, take this as 1 point, this as 1 point, and this is 1 point. So Q1. So this is your Q1, Q2, Q3. Q1 is basically 3. Q2 is also referred to as your median. A tricky question that examiners can ask. Determine Q1, Q2, Q3 and also tell me which value out of these referred to as the median value. So Q2 is the answer. Now let's say we have even number of elements like say 7, 8, 4, 6, 5, 6, 3, 3. Sort them 3, 3, 4, 5, 6, 6, 7, 8. Now when you have to divide them, we can. So this will be Q1, Q3. Now Q2, how will we determine Q2? So Q2 will be 5 plus 6 by 2, that is approximately 5.5. So this is how you will divide it. Now, a very important question or a diagram, you can say this diagram. 25%. So if I say Q1, Q2, Q3, 25th percentile, median, 75th percentile. Now, if you get a question, find out the 25th and the 75th percentile of the given set of distribution. So that means you have to find Q1 and Q3. If you are told also find the median, Q2. Now, also this is a very important question. 5-number summary. Very important. It may not be taught in class, but it may be asked. A 5-number summary consists of first, median. Median is Q2. Second, quartiles Q1 and Q3. Then fourth will be your smallest observation. And fifth will be your largest. Now there is an order. If you write in this order, it may not be considered. So the order is minimum. Q1 median, Q3 maximum. Now, can you understand why the order is important? Minimum, suppose 1, 2, 3, 4, 5. It will be in ascending order. So, median is 3, Q minimum is 1, maximum is 5. Q1 and Q3 are already getting. Now, I had taught you one outlier concept. So, outliers are very nicely seen in box plots. So what is box plot? It shows us a range of values. It is a popular way of basically visualizing a distribution. So a box plot incorporates the 5-number summary. Typically, the ends of the box. The ends of the box are the quartiles. The box length is the IQR. The median is marked by the line within the box. Median. So I'll draw it on the next page. Wait. So this is your box plot. Okay. So ends of the box are the quartile. This is also quartile. This is your median. This part is your IQR. The median is marked with a line, two lines called whiskers outside the box. The two lines, just wait a minute, two lines, they are known as whiskers that extend to the minimum and largest observation. Minimum, largest, min and max. A common rule of thumb for identifying suspected outliers is to single out values. So single out values following at least 1.5 into IQR, above or below? Third, just wait. How do I write this? So above third and below the first quartile. So this is basically a common rule to identify the outliers. So this is your box plot. Next we have variance and standard deviation. So let's write the formula. So variance is basically variance sigma square is equal to 1 by n summation n from I is equal to 1 xi minus x bar whole square is equal to 1 by n summation xi square mm, minus mean square. Now we know that standard deviation or SD or sigma is equal to under root of variance, or you can say under root of sigma square. So this is the formula. So this is all for this video, where I talked about data collection and how do you understand the data. I taught you box plot representation, how to understand your data. This part is really important in terms of analyzing your data. This is the first step. There are many types of graphs, many types of visualizations that we'll be seeing later on. So if you like the video, do like, share, comment, and subscribe to my channel. So thank you. If you have any doubts, do mention in the comment section. I'll be answering them as soon as possible. So thank you. Bye bye.